Welcome back, students. Thermodynamics. Thermodynamics is a horror among students, but after watching this video, you will find it easy and we will learn some concept of thermodynamics by solving this question. So first, this question is enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are given to you. Now first, what is enthalpy of combustion? So enthalpy of combustion is amount of energy or enthalpy change when 1 mole of compound, element or atom burns in excess of oxygen. Whenever there is a word enthalpy, that is for 1 mole. Always for 1 mole. And combustion means, burning in excess of oxygen, not limited supply of oxygen. Okay. For example, first is enthalpy of combustion of methane. So to write equation, first we write methane. Methane is a gas. We burn in the presence of oxygen. Oxygen is also a gas, and it gives CO2 gas and H2O liquid. Because at 298 Kelvin, H2O is a liquid. Okay, so we write it as H2O liquid. Now balance this equation. Keep methane 1 mole. By keeping methane 1 mole, balance this equation. So we put 2O before H2O. So carbon and hydrogens are balanced. Now balance the oxygen. There are 2 oxygen, total 4. So 2O2. And what is enthalpy for this? It is minus 890.3. So it is minus 890.3 kilojoule. Okay. Now second is graphite. Now graphite is allotrope of carbon. So carbon in the form of graphite burn in excess of oxygen. So when carbon burn in excess of oxygen, what it gives? CO2 gas, because oxygen is in excess, and enthalpy of combustion is minus 393.5 kilojoule. They are kilojoule per mole, and that's why it is enthalpy of combustion. Enthalpy of combustion. C stands for combustion. Delta stands for change, and H for enthalpy. So it is enthalpy change of combustion, or we can say enthalpy of combustion. Enthalpy of combustion of graphite, enthalpy of combustion of methane. Last is enthalpy of combustion of dihydrogen. And dihydrogen is H2 gas. So it burns in excess of oxygen. So we get H2O liquid. So what is enthalpy of combustion? Minus
285.8
kilojoule. Right? Now balance this equation. Keep H2 1 mole. So H2 1 mole, H2O liquid 1 mole, because 2H are there. What about O2? Half. Very good. So this is the equations extracted from first statement, that enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are this one. So these are the equations obtained. Now what we need? Enthalpy of formation of methane. That we have to calculate. Now what is enthalpy of formation? I think you know now what is enthalpy of combustion. Okay. For 1 mole of compound or element or atom, when we burn in excess of oxygen, the enthalpy change is known as
Enthalpy of combustion.
energy released, because combustion is always an exothermic process, right? Now, enthalpy of formation. So it is the amount of enthalpy change when 1 mole of compound is formed. Now, 1 mole compound is formed means product side there is only methane gas, because that we have to form from its constituent elements, and one constituent is carbon in the form of graphite, because we take most purest form of carbon and most purest as well as thermodynamically stable form of carbon. So thermodynamically most stable form of carbon is graphite, right? And along with H2 gas, how many H2 gases? Two. So this is the equation of enthalpy of formation of methane that we have to calculate, and it is represented like this. F stands for formation. Same way, change, H enthalpy, F formation. So this is enthalpy of formation of methane. So by using these three equations, we have to calculate enthalpy of formation of methane. Now, to obtain this equation, we have to rearrange these three equations, right? Now first, what we need?
Graphite.
Carbon graphite. How many moles?
1 mole.
And on which side?
Left side.
Left side. Now, from these three equations, carbon graphite is in
Second equation.
second equation. How many moles there?
One.
Same side, same moles.
Same mole.
So we keep this equation as it is. Okay. And take this as delta H2. Now, hydrogen gas. How many moles?
2.
On left side.
Left side.
Here H2 is on left side,
Left side.
but moles are
1.
1. So we multiply it by
2.
2. So 2 into half, 1, 2. If we multiply this equation by 2, we have to multiply same number with the enthalpy. So that become minus 2 into this,
2.
and take it as enthalpy of delta H3. Now come to this side. Methane gas on right side, and number of moles 1.
1.
We have methane gas but on
Left side.
left side. So we reverse this equation. When we reverse this equation becomes 2 CO2 gas plus 2 H2O liquid to methane gas plus O2 gas, 2 O2 gas. This is the equation. Now, when we reverse the equation, sign change. There is a sign change. Means it become positive. If we reverse the equation, signs from plus to minus, minus to plus.
Plus.
If we multiply the equation, accordingly, we have to multiply enthalpy. Right? Now, when we add these three equations, we get this equation. Say, carbon graphite, 2H2 gas. Extra is CO2 gas. So, CO2 gas is cancelled by this CO2 gas. 2H2 liquid, 2H2 liquid. And what do O2? 1 O2, 1 O2. 2 O2, 2 O2. Means if you are arranging this equation in a correct manner, then you get the final equation. Right? Now, as we add these three equations, we get this final equation. accordingly, same operation we have to do with the enthalpies. Whatever operations you are performing on these equations, same operation you have to perform on the enthalpies, right? So as we add these equations, so these enthalpies are also added. That means enthalpy delta H1 plus delta H2 plus delta H3. So that implies enthalpy of formation of methane is equal to, what is delta H1? Plus 890.3 kilojoule plus delta H2, it is
minus 393.5
plus third minus 2 into 285.8, and when we add these equations we get what is the value? 285.8 into 2, it is, yes, 1.6. So 8 plus 890.3 is plus minus 393.5 plus minus, and 2 into 285.8 is 571.6. So if we solve it, it comes out to be minus 74.5 kilojoule. Now we write it kilojoule per mole because it is for 1 mole of methane. So in this way we get the solution of this question as well as definitions of enthalpy of combustion, enthalpy of formation and laws of thermochemistry. When we multiply the equation by 2, same operation is done with equation. If we add the equations, same operation we have to perform on enthalpies. Okay, and one more thing, Hess law. What is Hess law? When a reaction takes place in one step or series of steps, enthalpy change involved is same. So this is the application of Hess law as well. This is one step reaction. These are 3 steps of the same reaction. If initial and final product, initial reactants and final product is same, enthalpy change is same. So this is known as Hess law. If a reaction takes place in one step or series of steps, enthalpy change is same. Thank you very much for watching this video. Please like, subscribe and share my video.